We're here at the New York Hall of Science at the 2013 Maker Faire. The Maker Faire is an annual event held at the New York Hall of Science. Inventors and creators showcase their work. Music, crafts, robots, demos and lectures, and just about something for everyone is presented during this weekend event. People of all ages made this their destination.
It's called a MAME cabinet. It's a cabinet that's designed to run old classic arcade games. So it runs an emulator called MAME, and it runs all the old arcade classics. So I wanted to build it because I wanted to play the old games, and I wanted to play them with joysticks and buttons instead of a computer keyboard. And that's it.
And tell us a little bit, okay, obviously different games have different components, joysticks, trackballs, paddles. What are your thoughts on what you're going to do in the future coming up?
Sure. So my goal was to keep this as authentic as possible to a joust-style machine, which had joysticks. But I also want to play games with a trackball. I want to play games with spinners. And so what I want to do in the future is build, say, a mini Centipede machine. So I can put a trackball on there and keep it as authentic as possible, since Centipede had a trackball on it. But I also want to put a spinner on there. So different cabinets that really feature different kind of control mechanisms, and then I'll be able to play those games. So if I have a spinner on a game, then I can also play, say, Tron, for example, and Tempest. So on the planning board, I've got a mini Ms. Pac-Man machine, I've got a mini Centipede machine, and a whole bunch of others that I've got up in my head right now.
And what inspired you originally? Because obviously anyone could play classic games at home. What is it about the full arcade experience that you missed?
So I love playing the games, but I was never really good at them. What I really liked was the entire experience. So that's the games, it's the sounds, it's also the imagery. So what I've done on this machine, which is unique to pretty much every main cabinet, I've also got a monitor up top in addition to the main monitor. And so I'm able to show the original marquee graphic that goes along with the games, and I also show the bezel graphics. Those are graphics that go around the original games. So as you play it, in my opinion, I think it draws you further into the game by presenting you with this full art package. And sometimes I just like to turn it on. I just like to look at it. I think it's it's great. It stands on its own. It's like a thing. It's even better when you play the video, the game, the sounds, the images. It's you get the joysticks in your hand. It's a wonderful thing to sort of go back in time and play some of these classics.
And I think, like you said, like the cabinet art and art, that's such a major part of the games. It's part of the full experience that we really missed out on nowadays, too.
Yeah, there's a lot of this that I kind of obsessed over, and again, the idea was to keep it as true as possible to the original. So this is a Williams game. So I wanted it, and it's a Williams Joust game. So I didn't want to do things that the original Williams Joust game didn't have on it, because if you're someone like me, you walk up to it and you instantly recognize it, and you get that feeling of playing Joust and walking into an arcade and seeing it there. So the only concession I really made was to add a second button for each player, but that's basically it. So there's an incredible attention to detail to make sure it's as close as possible to the original.
And one more question. What do you think? Obviously, people are so into, Grand Theft Auto 5 just sold $1 billion. Do you like a lot of the new games, or do you really like to live in the past? Do you like the classic games more?
I think the newer games are very cool. However, as a parent of 2 kids, it's a little bit difficult for me to really devote the kind of time required to get into, like, GTA 5 is out now, and I would really like to play it, but I would get sucked in and I'd be gone. These games to me are like potato chips. I can play one, I can sit down and play a couple of games of Pac-Man. I get home from work, my son wants to play Rampage, my daughter wants to play a couple of games of Tapper. It's easy to get in, play a game, and then get out, and then go on and do your other stuff. So newer games are awesome, but these games are easy to get in and start playing them.
this device, it's two pieces. It's an analog synthesizer that's powered by a foot pedal. So the foot pedal generates its own electricity by oscillating magnets through copper wire, similar to like one of those flashlights, the safety flashlights. So you rock it back and forth, it generates electricity, and then you can power music through an analog circuit. I was always interested in like hacking toys and stuff like that, and it just kind of came out of that, like wanting to make noise, wanting to play with electronics. First is a Heck-Schmidt trigger. It's an oscillator. It generates a sine wave when you put electricity through it. The second is a NAND gate, which kind of regulates the waveform. And then the third is a CD4040, which splits the frequency by powers of 2 at each gate. So you get these 12 frequencies from low to high.
So the name of the company is RoboFun, and we are here to just, reach a little bit further out, to let more people know about the educating through technology that we're doing. So we're essentially teaching kids about robotics and video game design using platforms such as the Lego NXT and Scratch, which is through MIT Media Labs. Now, for instance, for robotics, we're using the NXT, and that allows us to show the kids a platform that they are familiar with because it's Lego. So they already know how to put those things, those pieces together. And then the programming aspect of it is what we really try and drive in. Because once they get a lot of those core concepts on how to build and how to put all the different things together and how to have a robot, then it's how to have sensors and how to have the programming to bring all those things together, to interact with one another. And then from that, then you have Scratch. Now, Scratch is an environment that allows them to have a graphical user interface, meaning that they can create characters that can interact with the user. And the way that it does that is through the programming language. Now, these kids are not going to be using something that's text-based where you're dealing with words to really have to type anything in. Instead, they're going to be using icons where they're dragging and dropping. And it's a lot easier for kids to understand because they see it, they look at it, it's colorful, and they're like, wow, okay, I get that. And time after time, they're able to connect all these things together and have a working program. And that's what we're really here to focus on, the education behind what's going on here at Maker Faire. So RoboFun's idea is just to reach out to everyone, because technology is really why we're all here. It's really what we're all interested in. And it's really what we want to be carried on by the next generation. And the way that we're doing that here at RoboFun is by making sure that these kids are getting the basic knowledge they need in order to go into engineering, in order to go into computer science or software development. And that's really what we're doing. It's called the Robo 23. It's a ball shooting robot. And what it does, essentially, you would turn it on, and you're going to use these 3 buttons right here to control this motor. So for instance, we're going to turn it all the way on. Is it test bit? And there you go. And with that motion alone, the kids just go crazy.
Play as a band, and we also do a lot of mod work and make kits and things like that.
Sure. This is our 3rd Maker Faire, and we love this place. A lot of like-minded people and just inspirations everywhere. It's great to see other people doing crazy stuff, and it's great to share our crazy stuff with people. One of the methods we use is called circuit bending, which involves taking apart battery-powered children's toys and electronic instruments, and while they're taken apart, rewiring them and finding new sounds, basically just finding finding new ways of getting crazy sounds out of them. So that's what we've done. We have a couple drum machines here, an old Speak and Math from old learning tool.
Appropriating ancient technology and making it better. So yeah, on this side is digital stuff, and on this end it's all analog. We've got the Roland TR-606 drum machine that I added a lot of features to the analog sound path so you can really shape the sound. And over here, we're using this to sequence our bleep kit, which is an analog synth in a box. Basically, it lets you make some interesting sound effects. But yeah, you can create any kind of shaped sound that you want with 6 different oscillators. It's a lot of fun. And then this TV has a similar technology in it. That there is a little analog synth, and it drives the picture tube as well as the speaker, and it's photosensitive. So when you wave your hand over this, it changes the pitch, and you can gate it with your right hand.
Dragon's back out on the track. How many laps has Dragon completed, Patrick?
The Dragon has done 29 laps. 29 laps.
29 laps for Dragon. It's amazing that they're completing these laps after so much work they've had to put into that car, but they're back out there. They're doing their best.
3D printing is really getting on, and it's more and more companies are getting involved into the 3D printing scene. And I believe that what sets our company apart is that we are an open source company. So we believe that sharing your knowledge is more important than individual success. And also our printers are open source, and the software that we use is also open source. And as a comparison of what our position is within the market, and the latest Make magazine review, we had our Ultimaker tested, and it was rated as the most accurate and fastest 3D printer amongst the 15 most popular brands. Of course, I feel that we get a lot of recognition from the Netherlands because we're based in the Netherlands, and people feel more comfortable buying a product from a Dutch company instead of importing it from the other side of the world. So we have a pretty good market in the Netherlands, and we're making a pretty good name for ourselves. But United Kingdom, Germany, and the United States, I believe those are the most active, involved countries in regard to the 3D printing. There are basically 3 different types of 3D printing. They're called FDM. That is also what the Ultimaker is using. You have SLS and SLA. The real filament is on the back, and it's being fed inside this Bowden tube by a drive bolt. It's being pushed forward into the hot end, and here at the aluminum block it's being melted, and the nozzle extrudes the filament. We have a large variety of users. For example, we have a few architects. I believe it's very attractive for them to easily 3D print a model instead of making the structure yourself. We have a lot of artists, and it is great for prototyping and customization. So basically all the fields that you are involved in making parts. If you need to prototype anything, you can do it with 3D printing, and that's very cheap and very fast. You can print a model, you have it within a couple of hours. You can see how it works, you can make some more changes, and then within no time you have your final product.
We're trying to make things really easy for the users. So a lot about what we do is working with existing hardware manufacturers to help develop a set, basically a library of all these pre-configured profiles that'll work great with the machine right out of the box. So we're trying to save our users time and hassle by doing this for them. We've got a staff of people with a whole bunch of printers in front of them, and they're really good at calibrating. So this way, when you buy a printer, you've got great settings out of the box. On top of that, a lot of the software that's out there right now has a pretty good feature set, but it's missing some of the features that you'll find in the higher end packages. So a lot of the big companies that are even here today, like 3D Systems and Stratasys, they've invested millions of dollars in investing these very high-end software programs. So we're trying to really offer a software upgrade for these desktop 3D printers to kind of bring the field up to where some of the high-end printers currently are. Basically, this kind of all starts with some kind of a digital model. So you may have designed that model yourself using a CAD package for a computer-aided design package. Or there's sites like Thingiverse.com, for example, that have millions of models that you can download for free. So the Yoda, the Owl, a lot of these parts that we have here today, we didn't actually design those ourselves. We got them from Thingiverse. So once you have the digital model, the next step is you bring it into the software, and you can scale it, you can orient it, you can basically position it exactly like you want it to look when it's eventually printed out. So it's going to create a set of instructions that you will eventually send to the machine to actually create the final part. So the last step is to then take those instructions and either stream them to the machine maybe over a USB cable, or a lot of times you can just put them on something like an SD card, plug it into the machine, and hit print. So it's not that hard. It's maybe not magic just yet, but we're getting there, yeah.
How do you get across information about 3D printing? Because a lot of people are laymen, they don't know a lot about the new technology. It's still overwhelming for them. How do you make sure it's accessible to everyone?
Maker fairs are a fantastic forum to do that. I mean, it's great to catch the kids when they're young, they come over, they're excited, they bring their parents, and it just kind of starts this great dialogue about what 3D printing is and how important software is, because it really is about, you know, the hardware and the software. It's two pieces that you have to have together in order to have a good print. So, you know, things like this, and it really is a growing field. So there are magazines and, you know, internet sites and, you know, support groups that help people to really get in the door to 3D printing. So even though it might be new to some people, there are lots of areas out there, people who are doing it and kind of learning together.
Well, this is Freeform Fashion, and what we do is it's a design service. I do some original designs, but I also help people create their designs as real wearable objects. And so the process to do that basically begins with a 3D body scan, and I use CAD design to create the thing. I put functional joints and hinges. I'm an industrial designer, so I'm very focused on ergonomics, body mechanics, and human factors. So I always make sure everything's functional, done in the right material, and add a lot of creativity as well. So one of the important things about the way we do it is you can draw on the body. I usually just draw directly on the model's body, use full color 3D scanning, and then that way all that information is put in there. I know where all the bones and muscles are and joints are, and that means I can make it perfectly fit and exactly the way I intended it to be shaped. Most people doing printing are doing it on home printers, which are just the extruding of one color plastic. All of these color things are Z-Corp prints, so basically it's a inkjet machine, regular printer heads printing on plaster, layer after layer. Then I coat it in epoxy and you get a nice glossy finish and a strong shape. They're just a little brittle when they're made out of color. All this other stuff is laser sintered nylon, so it's nice and flexible and great for wearable designs. They also have some rubber-like materials out now as well. And also I work with some stainless steel, whatever works right for the project. I do mostly my own designs, but I love collaborating with people and making their vision come to life because I've got a real kind of aptitude for the 3D modeling and for the production process. So for example, I worked with an artist on this project who does not do anything with computers, but she helped me come up with a design, make it exactly the way she liked. Veronica, she designed her own mask that I had her wear. And so it's really the heart of the program, the company that I'm trying to develop, is that I want to help others create what they want to make. Although yes, if you just have a vague idea, I can make it happen.
What we do at M3DI, we design and develop the 3D scanning software and hardware. This is 3D scanning technology has been around for a while, but it's been hard to use and mostly too expensive to be put into different applications. And what we do is we create custom systems based off of off-the-shelf components and a smart software that's able to extract high-quality information from low-quality hardware. In terms of 3D printing, what this allows you to do is capture real geometries as they are in 3D space. 3D scanning technology allows you to digitize physical parts and allows you to then recreate them or redesign them or modify them in any way for 3D printing or additive manufacturing technology. The 3D scanning system itself is based on line of sight. Think of it as taking a picture. When we take a picture of an object, we get not only the object but everything else in the background as well, and we get whatever the line of sight is. Whatever the line of sight is. So whatever the sensor can see is what it can reconstruct. So anything that's on the back face or that's hidden or that's in shadow, it's not going to be able to reconstruct the geometry. And so in order to get a full 3D scan of an object, what we're going to do is take several 3D pictures, in a way, of the object from different views, and then we're going to realign all those views together and merge them into a solid object. So for example, on the screen here, what we do is we have a single view and we rotate the object. We present different views of that object to the scanner so that it's able to reconstruct those surfaces. So for example, in this first view, we have a scan, but we don't have any information on the back side because it can only reconstruct what it can see. And so what we do is with subsequent scans, we're basically building in more and more of that model until we have a full 3D reconstruction. And so when we look at the individual scan data, we end up with a bunch of different scans aligned to each other. And now what we need to do is merge them together into a single file. Notice that there's still a lot of holes in the data. In order to cover those holes, we go back and take views that we're missing, or what we can do is, if it's not critical areas, if it's just small holes and crevices that accuracy is not a big requirement on, we can let the software actually interpolate the data in those positions. And so what we do is we run the merging on the scanned files and we end up with the 3D data. So all the holes that you saw before, they're filled in, the software interpolates that area, and we create a watertight STL mesh that we can then send to a 3D printer for printing.
Shapeways is a community or a website where we make, buy and sell 3D printed products. So you can upload your model and we make it for you, 3D print it for you, and then ship it to you. And also, if you don't know how to 3D model, that's not an issue. You can go to our website and buy all the cool stuff that other community makers have made. And how this machine really works is there's a laser on top here, and this is the whole build tray. And this build tray has layers of powder and it sinters. So every time it lays down a layer of powder, the laser on top, it sinters the powder at the parts where exactly it's supposed to be, so that you can get a final product. And this is an example of what a typical tray would look like. So what we do is, since we're trying to get the best prices for us and also our customers, we try to pack our models as closely as possible to get the most efficiency out of the machines. So this is what a typical tray would look like, and we can print over 100 to 200 parts at one go. And this is the build platform, and that's the laser, and every time it makes a run, the laser sinters on top of it, and it keeps on going till you get a final product in your hand. We also have customized apps where you can customize your own things. So rather than going to a shop and buying your own product, you can just go to our website and buy all the cool stuff. And not only that, you can customize your own rings and napkin rings and other different things with your name on it, or however you want to design it. So you can have a 1 in a million product which no one else ever can make, and that can be yours with 3D printing. It makes it possible.
Does this totally mean that jewelry makers don't need kilns anymore? Is that something that's in the past now if they use this technology?
You know, I think we'll see both things happen. So it's not going to necessarily replace handmade or custom manufacturing, but what you'll start to see is people will start making products for themselves, or really opening up like new possibilities. So my mom is actually a jewelry designer, and she has drawers of inventory at her house, and you know, she'll probably never sell those products. And so today, you don't actually need inventory anymore, and so I think for a jeweler, that could really unlock new possibilities with lower capital costs as well. Yeah.
And of course, you know, artists always talk about the, you know, the handheld effort, the individual touch. How do you apply that to something when it's 3D printed? How do you still give that artistic, that individual feel?
You know, 3D modeling is not super easy yet, and so there is still a lot of kind of like artistic and hand holding that goes into making that design. And then once it's produced, we do a lot of final touches, so there's still a lot of human effort. I think it's not just, you know, close your eyes, magic, this thing is here. So I think it's a bit of a balance. It just means that more people can get involved in a process that was typically very closed off before.
Until next time, this is Illumide signing off from the 2013 Maker Faire at the New York Hall of Science. By body.
Just the math. That's interesting. Another way. Thank you.
Thank you.